Good afternoon, students. My name is Professor Vandana Rai. I'm from Computer Science Department from SISTec Ratibad College, Bhopal.
Now, what is ISO OSI model? ISO stands for International Standards Organization, which is established in 1947. And now, question arises in our mind: who is ISO? So, I'm going to explain you about something related to ISO. ISO is a network of standard institutes from 164 countries. Its central office is in Geneva, Switzerland. Okay, from there they will operate. And ISO is a non-governmental organization. It is not government organization. It is non-governmental organization that forms a bridge between the public and the private sector. Okay, then ISO is the largest standard organization in the world. So, what is ISO? ISO is a network of a standard institute. So, now next question arises: how does ISO work? What is the procedure? How it is work for uh, different institute and different countries? So, it is important to know how ISO work. ISO not certify any group directly. It will not certify any group directly. Rather, some certification organization are there who will perform that task. Okay, they certify an organization's quality management system. Quality management system of organization will be checked by these institute, these organizations, and then they will provide this certification. Once your organization gets certified, your organization will receive a certification mark that you can use on your stationery and website. This is the procedure of ISO's working. And ISO is an organization, and OSI, which is developed by ISO, which is a model. OSI is the model. OSI stands for Open System Interconnection, which I am going to explain you further. So, OSI model. OSI stands for Open System Interconnection, developed by ISO organization in 1970s. What is the meaning of open system? Open system is a set of protocols that allow any two different systems to communicate. OSI is used to understand the procedure when how one computer will send the information or data to the another computer in computer network. It consists of 7 separate layers. OSI has 7 layers and they are separated but they are related to each other. Means whenever we send any data from one system to another, the data will go layer by layer and every layer will perform their own separate task, and data will be sent to other side, means receiver side. And at the receiver side, receiver will receive data, and there are also the OSI model will work from bottom to top at the receiver side, and at the sender side OSI model will work top to bottom. So data will travel from top to bottom at the sender side, and at receiver side data will travel from bottom to top. Each layer defines a part of a process of moving information across a network. In the network, how data will move, each layer of OSI will define how the process will go through and move the information from one system to another.
This is the OSI model, and OSI model has 7 layers from 1 to 7, from bottom to top. First one is physical layer, second is data link layer, third one is network layer, fourth is transport layer, fifth one is session layer, and sixth one is presentation layer, and last is application layer. I'm going to explain you each layer in further slide.
Now I'm going to explain you how OSI model will work. OSI model is a logical organization. Just tell you what are the different levels from which data has to travel from client machine to server machine. Now, what is the client machine and what is the server machine? A machine that is sending a request is a client machine, and the machine which is receiving that request, that is a server machine. Suppose there is a node 1 and node 2. Node 1 is sending some requests, so node 1 is the client machine, and node 2 is receiving some requests, so node 2 is the server machine. At any point, it could be changed. Maybe node 2 is sending any request and node 1 is receiving any request. So in this case, node 2 is the client machine and node 1 is the server machine. So OSI model is the physical and logical organization of the network. Now come to the layer of OSI model. First one is the application layer. Application layer is the users layer, where if someone want to send data, files, video, text, anything, that it will as it is in the application layer. So application layer will decide whether it should be done or not. So it will send to the data to the presentation layer. Then the presentation layer is responsible to accept the data and transfer that data into that form that is acceptable by the server machine. Because at the server machine, maybe some configuration will be different. So presentation layer will decide how data will be presented and how data will understand by the server machine. Then presentation layer will transfer this data to the session layer. The session layer is responsible for establishing a session, because session establishment is necessary. Let's suppose server machine is switch off. Then is it possible to send a request to the server machine? No, it is not possible. So this is the responsibility of session layer to establishing a session. Now, when the session is established, data, data will be sent to the transport layer. Now, students, till this from the application to presentation and presentation to session layer, data will remain same as it is, and when data received by the transport layer, here packet switching will be applied. What is the packet switching? Here transport layer responsible for dividing the data into smaller packets. Small transport layer will divide the data into smaller data into smaller packets, and it will send those packets to the network layer. Now the network layer break it down into further smaller packets and add source and destination address to those data packets and some protocol. Network layer attach some protocols to it, so that it can travel to the next layer on the server machine. Now, after this, data will come to the data link layer. Now, data link layer will will perform two functions. It will attach start and stop flag at the starting and the ending of that data. And one more task is provided by the data link layer is the error checking. It will check in all the upper layer whether there is any error in the data, or data is correct or data is incorrect. If data is incorrect or there may be any error in the data, so data link layer will request to the upper layer to resend that data so that the correct file can be sent. Now, after data link layer, data will transfer to the physical layer. Now, physical layer is the actual layer where data can take place to transfer data from some optical file or transmission media. Physical layer will define some interface, transmission media, mode of transmission, whether it should be simplex, half duplex, full duplex. And in the physical layer, data will be in the form of bits or bytes. Bits means 0 and 1, which is binary bits. Binary means 2 digit, which we can say 0 or 1. So as our system understand only binary language, so bits will be transferred through a physical media to the client side, sorry, server side. So at the server end, lower layer, which is the physical layer, will receive that data. And now what happened at the server end? Now something opposite will be done at the server end. Here at the physical layer, data will receive in the bits form, and here we have understand that client machine, data link layer of client machine will add start and stop flag. Then here data link layer of server machine will remove those flags, and here network layer will perform to rearranging those packets which will received by the data link layer. Now, exactly opposite procedure will follow at the server end. So, at the transport layer, it will assemble those data, and at the session layer, it will make sure that during the session data will not lost and session will be established. And at the presentation layer, then data will go to application layer. Exact what type of file, video, or text data which which client machine are sending will be received by the server machine. This is the procedure how client and server will communicate using OSI model. Now physical layer. The physical layer is responsible for moving individual bits from one node to next node. Means physical layer data will reside in the form of bits. What is bits? Bits means 0 or 1, which is called binary language. As I already explained you that what is the binary language, our computer will understand binary language, which is binary means 2 digit language, which is 0 or 1. So data will reside in the form of bits. Now when transmission takes place, bits will be encoded into signal. These bits will be changed into the signal. And physical layer also define the bit rate, means data transmission rate, representation of bits, synchronization of bits, line configuration, physical topology, and transmission mode. So I'm going to explain you one by one what is these all points. First one is physical characteristic of interface in media. Interface in media means which type of device or transmission media it will use to transmit those bits from client to server. So transmission media, you can say it whether coaxial cable, whether twisted pair, which type of cable, which type of medium it will use to transmit those bits from one node to another node. Now, second one is the representation of bits. The physical layer data consists of a stream of bits, as I already told you that at the physical layer data will reside in the form of bits, which is called 0 and 1. So physical layer is responsible to convert those bit into the signal and coded those bit into the electrical or optical signal. So this is the responsibility of physical layer to how bits will be represented into the signal. Now the third one is the data rate. So it is done by the physical layer. Data rate, how much data will be sent each second, means how many number of bits you can send from one node to another node in a particular time. It is also defined by the physical layer. In other words, you can say physical layer defines the duration of bits, which is how long it lasts. Now, synchronization of bits. So, synchronization of bits means at the sender and receiver side, whether the bit rate will be same or not. If sender is sending uh, 8 bits in a second, so receivers at the receivers and the bit rate will be same. In other words, you can say the clock must be synchronized. Both the senders and receivers clock will must be synchronized. Now the line configuration also done by the physical layer. It will check whether the connection is point to point or multi-point. In point to point, two devices are connected together through a link. In multi-point, more than two devices are connected into through a link. It is a link is shared between several devices, you can say. So it is physical layer also responsible to check whether how line is configured. Now, physical topology. In physical layer also responsible for choosing physical topology, defining how devices are connected to make a network. What are the physical topology? There are four types of physical topology I explained in previous video. First one is mesh topology, bus topology, ring topology, star topology. So, which type of topology is used by the network? It is also defined by the physical layer. And last one is the transmission mode. Transmission mode means the physical layer also defines the direction of transmission. Transmission mode means the flow of data, direction of the data flow. In simple, there are three types of transmission mode are there. In first one is simplex, half duplex, and full duplex. In simplex, only only device can send, or at a time only device can receive one one direction data, whether device can send or device can only receive. Half duplex, in half duplex two device can send and receive but not at the same time. Okay. In a full duplex, two device can send and receive at same time. So this is also done by the physical layer. Which type of transmission mode are going to be used? Now the second layer is data link layer. Here are some services which will provided by the data link layer. First one is framing, physical addressing, flow control, error control, access control. What is framing? The data link layer divide the data, whatever data received from the upper layer. What is the upper layer? Network layer. Whatever data received from the network layer, data link layer will divide the data into frames, data units. You can say it will divide the data into data units called frames. So this is called framing. And physical addressing means data link layer will add some type of address information of receiver. If it is receiving the data, then it will add that receiver's address, which is called header. You can say data link layer adds a header to the frame to define whether information about sender or receiver. So this is called physical addressing. from where data is receiving or whom data will be sent. Now flow control. Flow control, as I also explained, flow control means the rate at which the data is absorbed by the receiver, means how much data receiver can receive. Okay, then this is the flow control, and this should be synchronization. This should comes into synchronization, means if producing sender's producing rate is high and receiver's absorbing rate is less, then data link layer will control that flow. Okay, now error control. The data link layer also do the error controlling mechanism. If any case some frames can damaged or lost, then data link layer assure to retransmit it. And if somewhere there may be some duplicate frames also, so data link layer recognize that duplicate frame. These are called error control. Now access control. Access control means in network there are maybe two devices or more than two devices are connected to the same link. So which device will access the data at the at that particular time? Which device has control over the link at the any given time? You can say access control. Now third is network layer. Network layer is responsible for the source to destination delivery of a packet, and it is source to destination delivery of packet means network layer ensure whether that packet is receiving by the destination or not. Okay, and logical addressing. Second is logical addressing. Logical addressing is done by the network layer. In previous in data link layer, we have studied physical addressing. Physical addressing done by the data link layer, and here network layer perform logical addressing. Logical addressing means if a packet passes the network boundary. So we need to ensure that whether that packet is receiving or reaching on its proper destination or not. So network layer adds its own header to the packet coming from the upper layer, and then includes some logical address of the sender and receiver. This is called logical addressing. And routing, as you all know what routers do. Router will route that packet or send that packet to a proper destination. When in case of independent network, we can say there may be let's suppose there is a large network. The connecting device which we are using in this large network is called routers and switches. We use to connect uh, we'll use to connect various devices in a large network. Then they will perform this routing. They will switch the packet to their final destination, route that packet or switch that packet to the final destination. This is also done by network layer. Now fourth one is transport layer. Transport layer is responsible for process to process delivery of the entire message. Okay, a process is maybe any application program which is running on the host, you can say. And the second one is service point addressing. Service point addressing means in service point addressing means let's suppose in computer there are several programs are running at the same time. Okay, then source to destination delivery means delivery not only from one computer to the next computer, but delivery from one specific process which is running on your computer from one specific process on one computer to the same specific process running on the other computer. This is called service point addressing. And in service point addressing, the transport layer will add some address called service point address, or you can say this port address for delivering the message. Okay. Now third is segmentation and reassembly. Segmentation and reassembly means a message is divided into segments form into a small segments with each segment containing a sequence number. Each segment will contain a sequence number. These number enables the transport layer to reassemble the message correctly upon arriving at the destination. What do you mean by that? Suppose we have some message and we divided that message into some segments, and we given some numbers to the segments, like there are 5 segments. We have assigned 1, 2, 3, 4, 5 to each segment, and we have sent that segments to the to the destination. At at the destination, when the segments all the segments are received by the destination, then again the arrangement can be done according to the sequence number 1 2 3 4 5 which we have assigned to that those segments. So segmentation and reassembly is called is done by the transport layer. Okay. Then connection control. In connection control, transport layer can either be a connectionless or connection oriented. What do you mean by connectionless? Connectionless means it treats each segment independent. One by one, it will and deliver to the destination machine. And connection oriented means transport layer make a connection with the transport layer at the destination machine. Transmission will be done from one machine to another machine. Then one transport layer of one machine will establish the connection to the transport layer of the other machine, and that connection will be till all the transmission till the transmission will not finished. That connection will be live, and after the transmission will done, the connection will be closed by the layer. This is called connection control. Flow control, I have also already explained it. Error control, already explained. Thank you. Now, the session layer. Session layer is the network dialog controller. What is this? What do you mean by that? Dialog controller? It establish, maintain, and synchronize the communication between systems. Okay. It is a dialog controller. It will allow two systems to enter into a dialogue, which means it allow the communication between two processes, whether it should be half duplex mode or full duplex mode. Okay. And then synchronization. Synchronization means session layer allow process to add checkpoints. Some checkpoint it will add into the data stream of data. For what it will add checkpoint? Why session layer use checkpoint? Here I am going to explain you with the example. Suppose if a system is sending file of 2000 pages, and it will advise to you that add some checkpoint after every 100 page you receive. Okay. To ensure that each 100-page unit is received or not by the receiver. So in case, what is the advantage of this checkpoint? In case if any data is lost or any pages is going crash or some error occurred and not received by the receiver, then session layer will give the facility to retransmit that particular page or particular data to the receiver in case of any crash happen. So synchronization will be done by the session layer. Now presentation layer. Presentation layer provide translation, encryption and compression. What is translation? Translation means, as we all know, different computers use different encoding system. So presentation layer, if uh, presentation layer is in the sender side, will change the information in sender dependent format, and if the presentation layer at the receiver side will change that information into receiver dependent format. So translation will be done by the presentation layer. And second one is encryption. Encryption means to assure privacy. Sensitive information can be encrypted by the presentation layer. And compression. Compression means data compression. Reduce the number of bits contained in the information. It will compress the data. Okay. And data can be any type of data. You can say multimedia data such as text, audio, video. Okay. This is a compression technique we use to reduce the size of that data. Now the last one is the application layer, which is the users layer. Application layer means where the user work, user interact. The application layer enable the user to access the network, and it will provide file transfer, access and management. What is the file transfer, access and management? How file will be transferred from sender to receiver, and the user, it will allow the user to access those files in a remote host and to manage or control file in the remote computer locally. These tasks are provided by the application layer. And third is the email service. The application provide on the base for email forwarding and storage. You can send mail, receive mail, you can store mail. Okay, these all services will be provided by the application layer. Now summary of the OSI layer. From the layer 1, you can see layer 1 is the physical layer to transmit bits over a medium. Okay, now layer 2, which is the data link layer, to organize bits into frame. It will convert bits into frame. And layer 3, which is network layer, it will what it will do to move packets from source to destination. Layer 4, to provide reliable process-to-process message delivery and error recovery, which is done by the transport layer. What is the layer 4? Layer 4 is the transport layer. And layer 5 is the session layer to establish, manage and terminate sessions. During the transmission, it will establish a session and manage that session and terminate after completing the transmission. Okay. Layer 6, which is the presentation layer, to translate, encrypt and compress data. I also explained it. And layer 7, to allow access to network resource. Thank you. Any query you can ask.